So now what we would like to move on and do is solve a system of equations involving 3 variables. Now, generally speaking, most times when we solve an equation, or a system of equations, with 3 variables, you're going to have most likely 3 equations. And the quickest way to do this is using elimination. So we're going to use elimination not once, but twice. So let's see how we're going to do this. Let's take a look at the first example. So the first thing that we're going to do is we're going to pick a pair of equations and we're going to eliminate one of the variables. Well, right off the bat, if I select the first 2 equations, it's actually already set up for elimination if I select the first 2 as my first pair. Why is it already set up? It's already set up to eliminate the y's because you have a positive y and then a negative y. So I'm going to pick those 2, the top 2 equations, to eliminate y. So we're going to eliminate y. Okay, now I need to pick a second pair of equations where I'm going to also eliminate y. They need to be 2 different equations though. So if I pick, well, let's see, if I pick the first one and the last one as my second group, notice they're also already set up to eliminate y. So let's go ahead and do that. We'll pick the first and the last one as my second group. And again, notice I have to eliminate the same letter I just said I was going to eliminate in the first pair, or else it's not going to help me at all. So let me pick that first equation and the last one. Okay. Now remember, the goal with elimination is to add these together and that the variable should go ahead and eliminate. Well, it's already set up to do so in these 2. We'll eliminate the y automatically. Then we can just add and subtract normally. Well, on this first equation, the y's do eliminate. And we have our 2x minus our x, which will just give me an x. But we also have a z plus a z, which will actually give us, because we're adding a 2z. Keep on going. We've got to add the other side as well. We have a 10 and a 1, which is going to, or sorry, a 9 and a 1, which will give us 10. Now we need to do the same thing for the other pair of equations, our second pair. Again, the second pair are set up the same way so that the y's will eliminate when you add them. Now adding up the x's normally, let's see what happens. We'll have a 2x and a 3x, which will be 5x. Adding up the z's, let's see what happens. We'll get a z plus a z, which will give us a 2z. And on the other side, let's see, we've got a 9 and 9 added together, which is going to give us 18. Now, why did this help us? Because now, instead of having 3 equations, we're down to 2. And we've only got 2 letters. We've only got x and z. So we're back to where we were doing equations like this back in section 7.1. We're down to 2 equations with 2 variables. All we need to do is elimination one last time on these 2. And we need to either eliminate x's or eliminate z's. Now what I notice is that both equations have a 2z in them. So they're almost perfect for elimination. What I'm going to do is just leave the second equation on the right, the 5x plus 2z equals 18 by itself alone. And then what I can do is get away with only tampering with the equation that was on the left. I can get away with just taking that one and multiplying it by, I can multiply it by a negative 1. That will give me a negative x minus 2z equals negative 10. Why does that work, though, is because now I'll have a positive 2z and a negative 2z when I go to add those two equations. They will automatically eliminate. So they'll add up and they will cancel out because one's a positive and one's a negative. Then I can just add my x's. Normally I have a 5x and now a negative x, which will give me just 4x. And this is going to equal on the other side for our regular numbers. We have an 18 and a negative 10. When added together, we just get a positive 8. Last thing we do here to solve this equation is divide both sides by 4, which will give me that x equals 2. Now, just like before when we did these, we're not done. This is only the first part to our final answer. Remember, our final answers are going to be triples in these, and we've just got the first part. We've got the x equals 2, the first coordinate. I need to now take my solution for x, my x equals 2, and plug it in either to, working my way back up, into that first or second equation in the middle. Doesn't matter which. I'm going to pick the one on the left just because it's a little bit easier to deal with, so I will plug in my 2 for x. Notice what will happen there. I'll get 2 plus 2z equals 10 when I plug in the 2. Well, then I'll subtract the 2 from both sides. And that will give me, let's see, a 2z equals 10. You'll divide both sides by 2, and that will get you z equals 5. And that's your next answer. Remember though, z, your points go x, y, then z, so our z is going to get plugged in last in the point. So our 5 will be in that last slot. Now I'm just looking for y. I've got my x and my z. Now I can go to any one of the first 3 equations at the very top that we started with and plug in the x and the z that we have, and we can find y. I'm going to plug it into this first equation here just because I don't want to deal with negatives. 2x plus y plus z equals 9. I just chose this one because I thought it was easiest. You can pick any of the 3. I'm plugging in an x and a z. I found what for my x. I got 2 for x, so I'll replace my x with 2. And I'm going to replace my z with 5. So I can do my multiplication. My 2 times 2 is 4. I've got my y and my 5. Okay, so continuing right along, we can combine our like terms. We've got 2 like terms. We've got a 4 and a 5, which is going to give us 9. So we've got y plus 9 equals 9. And we'll subtract 9 from both sides. And that gets us a y equals 0. That's going to be the last point to our triple, to our point that has an x, y, and z. So that's going to go in the middle. So our final answer is 2, 0, 5.